Hello, good afternoon to Mr. Mukhtar, and welcome to the presentation about distributed objects in the cloud, scaling microservice, a guide for developers and cloud engineers on efficient communication and distributed system. Let us introduce ourselves. Starting for me, my name is Pedro Leonardis Wijaja, and go to the next. I'm Niman Fofana.
And I'm Cristiano Ronaldo.
Okay, we will start the presentation now. Let's start by me. So, what are distributed objects? So, for distributed objects are software components that run on different computer in the network but appear to the programmer as local objects. And the first one is they allow methods to be called on object located in other process or remote machines. The second is this abstraction is crucial for building scalable and maintainable distributed systems. In microservice also, distributed objects facilitate seamless inter-service communication, often across different programming language and operating systems. So the microservice in cloud, there are three types of them. The first one is order service, payment gateway, and also inventory service. So it's just an explanation and example for the real world things. So consider an e-commerce platform hosted on a major cloud providers. So for example, like AWS and Azure, and then Hostinger, the application is decomposed into specialized microservice. The order service is to handle order placement and status. Inventory service is to manage stock levels. And then the last one is payment gateway is to process transactions. I think my part is done. And then let's go to the other presentation, which is Nima. Okay, the role of distributed objects, scalability, and interoperability. Improving scalability, distributed objects enable services and scale independently. If the inventory status load increases, it can be scaled out without affecting the other services implementation. This granular scaling optimizes resources used and cost. And the second one is enhancing interoperability by defining a standard interface for communication services written in different languages. Example Python, Java, or Go can communicate seamlessly. This independence allows teams to use the best tool for each specific services. The third one is facilitating loose coupling. They maintain a clear separation of concerns. Services only need to know the remote objects interfaces, not its internal implementation or location, contributing to a more resilient architecture. The evaluation of remote innovation. Early approaches laid the groundwork for modern distributed computing. Java RMI remote method invocation, a Java-specific mechanism allow one JVM to invoke method on one on an object running in another JVM. Excellent for homogeneous Java environments, but limiting in cross-language support. COBA Common Object Request broker architecture designed to be language agnostic using an interface definition language that is IDL to define remote object interfaces. It aims for maximum interpro, pro, interpolab, interpro, okay, interoperability, but suffered from complexity. Modern communication technologies. Today, the focus has shifted toward lightweight, web-friendly protocols based on HTTP. So, that is Simple Object Access Protocol. That is XML based protocol for exchanging structured information.
highly extensible with built-in security and transactions features, often favored in enterprises environment requiring strict contracts. REST representational state transfer, that is REST, an architectural style leveraging standard HTTP methods, like the methods like GET request, post, put, and delete, and resources. It is seamlessly simpler and dominant communication method for public APIs and internal microservices due to its lightweight, lightweight nature. That is the third one is gRPC, Google Remote Procedure Call, a modern high performance framework that uses protocols buffer, the protobuf for efficient serialization for HTTP2 for transport, ideal for performance critical interface inter-service communication.
Addressing distributed system challenge. Implementing distributed object introduces problems like network legacy, partial failure, and data consistency. Modern protocol provide built-in solution. Latency mitigation, REST or GDPRC used to efficient data format, or JSON or protobuf. Reduce payload size, asynchronous communication pattern, provide calling service while loading. Handling communication error protocol include reverse error codes and retrieve mechanism, implementing circuit breakers and time cascading value, and also data serialization and compatibility, protobuf or gRPC and JSON ORS. Provide cross-language serialization, ensuring data types are correctly interpreted across heterogeneous environments. Key takeaways for cloud architect. Successfully leveraging distributed object is vital for high performing cloud application. Number one, prioritize performance. For internal high traffic microservice, favor high efficiency protocol like gRPC over traditional REST for lower latency and smaller bandwidth use. And number two is designed for inter interoperability, ensure Fusion protocol support all the programming language used across your service landscape. And the last is embrace stress resilience. Implement design pattern like bulkhead, circuit breakers, and exponential backoff for retries to manage the internal volatility of network communication. And for the conclusion, distributed object from the backbone of
Cloud.
cloud native system, enabling in independent scaling, cross-language communication, and resilient inter-service interaction.
That's all from us. Thank you for hearing our presentation, and we'll see you in the next video, the presentation.